And I'm going to do a quick reminder refresher about how to graph our data for this experimental design project and analyze the equation for the trend line. So ideally, you have your data set up in a Google Sheet so that you have your independent variable in one column, like I have here. So this would be an experiment with a solar panel where we are changing the amount of sunlight the solar panel receives and measuring the amount of voltage that is coming out of the solar panel. So we have our independent variable in our A column here with, I put 10 data points. You're required to have at least 4 data points, but the more the better. And then in columns B, C, and D, I have my dependent variable, which is the voltage reading from that solar panel. And I took 3 trials of that so that I would be able to take an average and have more realistic data. You guys saw on those voltmeters how the data bounced around a lot. So taking 2 or 3 trials for each independent variable reading is going to be a good idea. But we don't want to graph those trials because all that data sort of muddies the picture. So what I want to do is I want to calculate the average voltage for each trial, and then we'll graph that. So in column E, I've made a new column that says average voltage. Make sure you have your units there measured in volts. And I'm going to write a quick equation, which you've learned how to do in class before, equals average of, and then parentheses, those 3 data points, close parentheses, enter, and it calculates the average. It may give you the option to autofill. That's reasonable here because we want to do the same calculation for everything in that column. So that is our average voltage. Now, if we graph these 2 columns together, okay, the way I would do that is I would click on the A to select everything in column A, and then I'm going to hold the Control key on my keyboard, and then click on the column E, insert chart, okay, and we want to create a scatter chart plot of this data. Now, compared to our previous experiments that we did in the fall, we may see something kind of different in this energy generation, and that is that we may have a graph that has a linear portion and then a portion that is nonlinear. So in this graph, I see the sunlight going up and up and up, and then at about 60 lux, I stop seeing that graph go up anymore. And there's a wide range of reasons why our graph might decide to not be linear anymore. And I want you guys to process that, what that looks like from your wind energy experiment. But in any case, with the goal being to optimize the amount of energy that we are generating, we might want to make our trend line on this graph only for this linear portion, okay? Because if I make a trend line for the whole graph, it's going to be like dragged downwards by that last portion. I might want to just see what is the line for the linear part, and then what is the equation for that line so we can analyze it. So I'm actually going to just take a quick look here, and I can see that I think my linear portion ends at about 70. Now this is a bit of a clunky solution to make a graph of just that portion. If you used a more robust program like Excel compared to Google Sheets that's better for data analysis, there's better ways to do this. But in Google Sheets, the only way I could really find to make a graph of just a trend line graph of just one chunk of the graph is to copy that data into another column. So I want the data just from 0 up to 70 in another column. I'm going to go ahead and get rid of this graph because I want to make a new graph. This time I'm just going to copy out the data from 0 to 70, okay, Control C, and I'm going to paste that. It's actually a little bit tricky. You need to do paste special values only, and the reason you're doing that is because we actually have equations in those cells, and if you paste just Control V paste, it's actually going to paste the equation, which will, calculate average again of a different set of cells. So in any case, I'm going to paste that, and I'm going to say, label this thing linear portion. And now I'm going to make a graph with all 3 of these columns in it. Column A, Control, column E, Control, column F. And hopefully this graph, okay, so this graph is kind of a mess right now because it's confused about what this data is. I'm going to change the chart type into a scatter plot. And then I'm going to tell it what data goes on each axis. So I want my sunlight data on the x-axis. So down here under x-axis, this is in the chart editor, which you can get to by those triple dots, I want to select sunlight on the x-axis, okay? On the series, which is the y-axis, I want to turn off sunlight because I don't want to graph the sunlight again on the y-axis. I want to graph these two things, the average voltage, which was my column E, and the linear portion. And the cool thing you'll notice is since the linear portion was to the right on the column, it actually sticks that data point right on top of the average voltage. So now you can basically see the linear portion of the graph highlighted in red, and that should match what you sort of eyeballed predicted this to be. From here, we're going to do what we've learned how to do before. We're going to go to Customize and Series, and we're going to do a couple things. The first thing is we're going to add error bars. Hopefully you've already done some thinking about what the reasonable size for your error bars should be in this graph. Remember, you need to turn it to constant. For me, I would say one thing that is sometimes helpful when thinking about how big an error bar is if you look at the data for each trial, you can sort of see what range of values we get. That's an also good indicator of how big your error bar should be. So if I look like I got a 0.4 difference here, that seems to be about the biggest. I don't see a gap in my data that is bigger than 0.4 volts. So I might say that likely we're going to be somewhere in the range of 0.4 for my error bars. And that looks pretty good when you think about fitting your trend line to it. Then you're going to go ahead and click on your trend line button. And what I want is this trend line not to be applied to all series, okay? I actually want the trend line only for the linear portion. So up here, still in the series tab, I'm going to click on the linear portion one, and we're going to turn off, or I guess the way I've done it, I need to turn off the trend line for the average voltage. Error bars are fine for both, but I don't want the trend line on there for the average voltage. I only want that trend line on for the linear portion because the line doesn't make sense for the average voltage. Although you can see why we took out that data set because it ends up stretching my trend line in a different direction. So anyway, in the linear portion, you should have a trend line turned on, and you need to click down here where it says label and say use equation. So that gives you the equation for that trend line just for the linear portion. At this point, you have a really nice slick graph, okay? The last portion of this assignment asks you to figure out the significance of that trend line. Remember that this equation that it gives you is in y equals mx plus b. So you could rewrite this as y equals 0.042x, in this case, minus 0.0857. And that's the math equation for that trend line. But in physics, those y and x variables have a meaning, right? Oh, actually, they don't on my graph. Okay, so my graph sort of dropped the labels on those two axes. If you want to put those labels back on again, you're going to go to Edit Chart, Setup, Customize, Chart and Axis Titles. Okay, and I'm going to switch this drop-down menu to Horizontal Axis Title. We need to switch that to Voltage measured in volts, and we need a vertical axis title, which is sunlight measured in lux. The other thing that's actually useful is to have your horizontal axes go to 0, 0. So you can see that we don't quite start at 0 on the horizontal axis. If you want to fix that, that's under Customize Horizontal Axis. You can set the minimum value to 0. You'll see that stretches my graph out, so I like that a little bit better. So in any case, now if I look at my equation, y equals 0.042x minus that number, I can replace the y value, or the y in that equation, with the word sunlight. Okay, sunlight equals 0.0. Dang it. Okay, I put my axes labels on the wrong direction. My x-axis should be my independent variable. So the thing that we changed, horizontal axis should be sunlight, lux, and the vertical axis should be my voltage in volts. Okay, so which makes more sense because the voltage should be the thing that we're measuring, right? So my y variable should be voltage equals 0.042 times the sunlight minus 0.0857. So this is a useful equation because it actually describes a scenario, right? It tells you what's happening in the physical world. It tells me if I want to know how much voltage I'm generating, at least for this range of linearness in my graph, I would just have to take the amount of sunlight I get multiplied by 0.042 and then subtract this little bit at the end. We ask you to identify the significance of the slope and the intercept in the y equals mx plus b format. The intercept is this last little value right here, the 0.0857. So I would say intercept is 0.0857, and we need units, right? This is the y-intercept. The units of that intercept are going to be the units of the y-axis, so which is volts. And if you think about the significance of that, it basically says that when the sunlight is 0, we're producing negative voltage. That doesn't really make sense. So in your analysis, you might say this doesn't really make sense unless you consider the fact that that y-intercept is within my error bars, right? It is less than 0.4 away from 0. So for all intents and purposes, that is actually equivalent to 0. It's within an error bar of 0. So I would say this is essentially 0, or this is within one error bar of 0, which makes sense because 0 light makes 0 energy. The other value that's important in this is this 0.042. That is known as the slope of the graph, the m value. So I would say the slope is 0.042. The units are going to be rises over runs, which in this case is volts per every lux. Okay, and just figuring out the units of that actually helps you figure out what the meaning of this is. This means that every additional lux produces 0.042 volts more energy. And this would be a really, really useful thing to know if you were using a solar panel and you knew how much energy you needed. You better figure out a way to get that much light into your solar panel. So anyway, thanks for watching. That was sort of as quick as I could make it through creating your graph and analyzing your trend line.